All right. Probability distributions and frequency tables. Okay. The table at the right shows speeds of cars at a certain mile marker. Okay. 2 grannies were driving less than 55. 12 people were taking a leisurely drive and driving between 55 and 60. 23 fairly normal people were driving between 60 and 65. And 13 Carson Wolves were driving more than 65. Leadfoot. All right, so there's how many people were speeding there? Well, what you have to do is take 2 plus 12 plus 23 plus 13. If you do that, you can see that there are, 50? 50 people driving, okay? So 13 out of the 50 were speeding, okay? 13 out of the 15 were speeding. This is a frequency table that, a frequency table tells you how many are doing some certain attribute, okay? So let's look at this table. This table has 40 total people surveyed. 10 people like rock, 7 people like hip hop, 8 like country, 5 like classical, 6 like alternative, 4 like other. So what's the relative frequency of liking rock music? Well, that's 10 out of 40, which is 1/4. So what is the relative frequency of hip hop? 7 out of 40. What's the relative frequency of classical? 5 out of 40, which reduces down to 1/8, and so on. Okay? So you just have to add up the total number and write fractions. Most of today's are fractions. Okay? A student conducts an experiment. Okay? There are the 8 possibilities of flipping 3 coins. Okay? Now, did it work out perfectly like the theoretical probability said it would? No. He was flipping 5 coins. This is experimental, so his results are all over the place. Okay? So, we want to know what's the probability of getting exactly 2 heads. Well, he flipped the coins 50 times. The exactly 2 heads were right here, and right here. So, if we add them up, hello. Yep. Yeah, they did. Yeah, I'm 90% sure that they went, unless they got called off because of weather. Okay. Yeah. Yep. All right. Yep. Bye. Okay. So 7 plus 6 plus 12 is 15. You got 15 out of the 50, or 3 out of 10 chance of getting exactly 2 heads by his experiment. Now, what's the probability of getting exactly 1 head by his experiments? Exactly 1 head. So you got a 9 here, a 9 here, and a 2 here, which is 20 out of 50, or a 2 out of 5 chance of getting 1 head. Okay. All right. So a student conducts a probability experiment by spinning the spinner shown, uses results on the frequency table to figure out what's the probability of getting a 4 on the next spin. Well, what's 29 plus 32? 61 plus 21 is? What, 72? 82 plus 18 is? 100. So he spun it 100 times. What's the probability of getting a 4 on the next spin going by his experimental probability? 18 out of 100, or 9 out of 50. Okay? A probability distribution shows the results. Okay? Now, in a probability distribution, They did not reduce the fractions. Okay? So when you write out a table with a probability distribution, you do not have to reduce your fractions. Okay? And we'll see that today on the practice worksheet. Oops, didn't mean to do that. Meant to go here and go here. So, take on your calculators 58 plus 48 plus 10 plus 28. Add them up, please. 144. What's the probability of preferring to listen to radio? 48 out of 144. What is that as a reduced fraction? Because it says simplify your answer. A third of the people prefer radio. Okay? So number 2 is a lot like that. Let's go to number 3. 100 randomly selected students. So you know this adds up to 100 already. Find the relative frequency of having no plans after college. No plans for college. Well, the do not plan for college is right here, so that's 7 out of 100. Here they want a probability distribution. So you add up 29, 398, 294, 125, and 154. If you add them up, what do you get? Exactly 1,000. So the probability distribution for under 18 is 29 out of 1,000. For 18 to 22, it's 398 out of 1,000. Here, it's 294. 294 out of 1,000. I don't know where that one came from. Here, 28 to 32 is 125 out of the 1,000. And this one is 154 out of 1,000. So you do not have to reduce when it asks for a probability distribution. All right, the bar graph at the right shows the number of players on 2 softball teams. Somebody's going to be selected at random to sing the national anthem. What's the probability that they're an infielder? Well, you have to figure out how many there are. Looks like there are 3 pitchers, 4 catchers, 9 infielders, 8 outfielders. So if we add them up, they add up to 24 total people. What's the probability that if somebody has to sing the national anthem, that they're an infielder? 9 out of 24. Reduce the fraction. 3 out of 8. Okay? So the snacks, when you look at this, there are 11 of these, 4 of these, 4 of these, and 10 of these. 11 and 10 make 21, and 4 and 4 make 29. So it's whatever out of 29. Okay? Probability not bananas. Well, if there's 11 bananas, not bananas would be 18.